question becomes, what do we look at next? We're going to look at what if the variable is in a denominator. And that's what we want to get rid of, is a denominator that has variables in it. Well, we're still going to do the same tactic. We're still going to multiply by an LCD. It just may have variables in it. So it might get a little bit messy. For this reason, we also have to be careful that we check our answer. We have to be careful that we're checking our answers. We could end up with what are called false solutions. Our false solutions are going to be answers that we get that don't actually work. A good example would be an answer that makes our denominator 0. You can't get an answer that will make your denominator 0. Why? Because you can't divide by 0. So we just need to take whatever answers we get for these fractions and we need to plug them back in to make sure they're not making our denominators 0. Let's take a look at this first example of an equation with variables in the denominator. So on this first one, we have 11 over x plus 13 over x equals 12. We're going to do the same tactic. We're going to look at the denominators, which are just an x, and we're going to multiply by the common denominator. Well, if the denominators are both x, the common denominator, the LCD, will just be an x. So we'll multiply each and every piece on both sides of our equation by an x. Well, starting on the left-hand side, what will happen is the 2x will cancel out, leaving you with just an 11. And on your second piece, let's see what happens. Again, you have the same idea. You have 2x's will cancel out, leaving you with just a 13. And on the other side, we multiplied by an x, and that's not going anywhere, so we end up with a 12x. Well, you can go ahead and just combine your like terms. You do have an 11 and a 13, which added together will give you 24 equals 12x. So to solve this thing, you're going to divide both sides by 12. And let's see, you get x equals 2. The question is this answer valid? Is it a false solution? Well, it's not going to be a false solution because a false solution would be anything that makes your denominator 0. And look, your denominators in your original problem were just x's. The only thing that would have made your denominator 0 was if x was 0. So the only thing you can't plug in for x is a 0. We did not get 0 for x. We got 2. So that answer is perfectly fine. And we can move on. That's a good answer. Let's look at another one. Let's look at problem B. Now, if you look at problem B, again, we're going to look at trying to find the common denominator first. Well, both denominators are x plus 6. So we're going to actually multiply by the common denominator, the LCD of x plus 6. Now notice, the only answer that is not okay in this problem that will make your denominators equal to 0 would be a negative 6. So the only thing we can't get here is a negative 6. So if we get anything but a negative 6, the answer will be nice and valid and we can use it. So let's go ahead and go on to the problem. We've got 3 over x plus 6 minus 2 equals 7 over x plus 6. So what we're going to do is we're going to multiply everything straight on through by an LCD of x plus 6. So our first piece, the 3 over x plus 6 gets multiplied by an x plus 6. The next piece, the negative 2, gets multiplied by an x plus 6. And don't forget the other side, the 7 over x plus 6 also gets multiplied by an x plus 6. Well, on the first piece on the left-hand side, you multiplied by an x plus 6 on the top, but that'll cancel with the one on the bottom, leaving you with just the 3 that was on top. On the second piece, we multiplied a negative 2 and the x plus 6, so there's nothing that cancels. We just need to distribute. So that will give me a negative 2x minus 12. equals, on the other side, notice again, we multiplied by an x plus 6 and we had an x plus 6 on the bottom, so those will cancel, leaving you with just the 7 that was on top. Now, all of our fractions have magically cleared. We do have a couple like terms here, luckily. We've got a 3 and a negative 12 that are on the same side, so we can go ahead and add them. Well, 3 and negative 12 will give you a negative 9. We also do have that negative 2x equals 7. Keep going like this was a normal equation. Add 9 to both sides to get the x by itself, and we get that negative 2x equals 16. Then dividing both sides by a negative 2 gets us that x equals negative 8. Again, is this answer okay? Yes, it is, because the only answer that we said wasn't okay was the answer of negative 6. We got a negative 8, so that answer will not make our denominator 0, so it's good, and we can use that answer.